Hey, please take a seat. We're going to start the next session. Por favor, tomad asiento. Vamos a comenzar la siguiente sesión. La sesión será en inglés y tenemos 5 presentaciones que serán en inglés. Voy a presentar rápidamente a los ponentes. So it's a pleasure to be sharing this table with 5 people. I will define them. I think what they have in common, all of them are more related to the university. They are either currently teaching at a university or they have taught in the university recently. It's more academic profiles. And we will see also that there is a nice connection, academic industrial connection also in the people that we have in the table. So I will introduce them very briefly in the order in which they will present. So the first one will be Oriol Pujol. So Oriol is a full professor at the University of Barcelona and an extremely prolific researcher. You will be delighted to hear his talk. To my right, there is Paul Carpenter. He is a senior researcher at the Barcelona Supercomputing Center, and he has been the research leader in several European and other research projects. Daniele Quercia, here in the left, he heads the group of social dynamics at Bell Labs in Cambridge, and he was named by Fortune magazine one of the data all-stars in a couple of years ago. That's a very interesting personality. And then we also have Josep Lluís. He's the head of the data mining group at UPC, the DAMA group at UPC. And something that I find very special about Josep is that his profile is both academic and has also a lot of industrial interest, including startups and collaborations with the industry, which is a very rare profile. I'm very interested to hear your talk. I can say the same about Liliana Napalkova. Liliana works at Eurecat. She's a senior data scientist in the Big Data Analytics unit. And she also has an interesting career that goes from more academic to more applied work. And I'm also very, very interested to hear all the 5 presentations. So without anything further, I would like to invite Oriol to start his presentation. I guess somebody will help me with the time. Like there is a 10 minutes time for that? Okay, one of you. So, thanks.
Yeah, hi, you hear me? Okay, so thank you very much to the organizers for having me here. My name is Oriol Pujol, and I'm a tenure associate professor at the University of Barcelona. And today I want to talk about a little bit about deep learning and also how can this help in the shared challenge of democratizing data. So I have told you I'm associate professor at the University of Barcelona. And some time ago, I was asked to think about the digital transformation of the university. And digital transformation of the university, if you think about how large a university could be, we are around 60,000 people involved in that university. And actually, the processes, the university dates back from several centuries. So you can imagine that the processes probably they have to be rethought if you think about digital transformation. So we have, as a university, we have large amounts of sensible data, and also we have a lot of different kind of data users so that can access that kind of data. But because we are a public institution, we also feel the responsibility, the social responsibility of actually engaging or being part of this data philanthropy movement, right? And whenever you think about the digital transformation of any company, of any organization, the key core point is data in the end, right? And how to manage data when you have this setting is quite difficult. No? So if you look for solutions for managing this kind of data, but while preserving privacy, what you get are probably techniques that kind of aggregate data, let's say, for example, K-anonymity techniques, But even if you're using this kind of aggregation techniques, there is also the risk, there is always the risk of some kind of disclosure. This is what's called differential privacy and this kind of stuff, right? So this actually means that if you know a little bit about the database and if you know a little bit what queries you have to ask, you probably can disclose some of the data inside, right? So let me just show you that, well, this data, when aggregated, there is a trade-off between this data utility and actually the anonymization or the privacy budget we allow or we want to give to the user. And this has been, well, this is a sketch of a graph, of a plot that was actually from last year journal, that they were actually trying to predict the dose of warfarin in patients using machine learning. And what they actually, they wanted to know how the privacy budget and the disclosure risk affected the dose that was predicted, right? And well, what they found is the following: as the privacy budget increased, the disclosure risk also increased, and the dose that was predicted was okay. But when the privacy budget was very low and the disclosure risk is very low, then the relative mortality, that was simulated mortality in that case, also increased. So this is a very fine trade-off, and we have to be careful with that. So if we want to actually take information from the data and we want to use or we want to share this data with the community, we have to consider this balance. So we have seen that there has been a change or a lot of fuss with techniques that are called deep learning, and there is a reason because of that. There have been real improvements in many domains, such as, for example, in speech recognition, where you can find here even commercial products like Skype Translator that it's able to recognize speech, translate the sentence, recognize the sentence, translate the sentence, and also resynthesize this information in near real time. And it can be done in several languages, and also it can be translated by writing in more than 40 languages or so. But this has also affected computer vision community, and you can see one of the challenges is to try to understand what's going on inside of the images. And actually, this is one of the applications of deep learning, in where the deep learning technique not only recognizes objects, but also the relative position of objects, and even they are able to caption quite well some of these photos. Let's take one of them, for example, the one on the left, this says, little girl is eating a piece of cake. So it's quite a good description of the picture, and it's everything done automatically. So let's, for all of you who are not, or have seen or have heard about deep learning but don't know a little bit what's this about, let me just sketch a little bit what's the underlying concept behind that. So in traditional machine learning technique, you have some data and you use a set of data scientists or domain experts to somehow take this data, extract some features, some minimum features with the goal that in the end, our final task or final classifier predicts something quite well, right? Okay, if you're actually using deep learning, what they want to do is precisely remove this part and change that with a learner, something that is going to be learned from the data, scratched from the data, okay, so that this data, when goes through the learner, it changes its representation, but the representation can also be meaningful for the task at hand, for the prediction task at hand. So this is the key concept of deep learning. Deep learning actually is able to create or learn good representations for the data. And actually, what you see is that the learner and the classifier goes hand by hand, and if you see what's inside this box, that you will see are neural networks, or all good friends neural networks that has somehow come back. And what changed, and why this kind of artificial neural networks, these are not the only kind of methods you will find in deep learning, but it's probably the one that has propitiated all the changes we have seen before. And what has changed from the start to now, or from 20 years ago where where neural networks were introduced? Well, we have more computational resources, we have big data available, and it's a crucial issue. And also, we have learned a little bit more about the optimization processes, and we fixed some bugs. So with this in hand, let me show you how this can be used to address the problem of shading data. So consider the following black box, which is a deep learner, and we have some input data, and we take this data, we process that with the deep learning, and in the end, we get the same data. Well, this seems like a stupid technique, but actually, if you look inside, what you see is that what we have is some bottleneck architecture, right? And this bottleneck architecture can be thought as the following. You take the data, you actually compress that into some unknown set of features, but this feature has the ability to be decompressed and actually, again, be able to reconstruct the original data, the original sensible data. And this is even more interesting because then you can take any classifier using that technique before, and we can plug in this original data, convert that into some representation that is meaningless for any user, but even if the classifier is, or task is not the one of reconstructing the original data, but of predicting any other thing, this information, this compressed data, actually preserve discriminant information so that we can use in many, many other tasks. But because I know that some of you know a lot about differential privacy here, let me just point out my last issue. So one of the concepts that is interesting here is that, okay, you got one representation, but actually the same data can have several representations. And all of them will convey exactly the same discriminant information. So this is extremely good, and this can be actually very useful for that. So what are my two messages here? So I wanted to give a basic intuition about what deep learning was about, and also how new machine learning methods can help in the challenge for democratizing data. So thank you very much, and I will gladly take questions at the end, or if you want to do something. Thank you very much.
Good afternoon. So what is big data? In a famous article, Jill Press at Forbes magazine gave 12 different definitions of big data, starting with the original NASA coining of the phrase to a more concise definition in the Oxford English Dictionary to a new attitude that could lead to better business decisions, which could be more or less anything. And if I ask in this conference, I guess we'd get 800 different definitions of big data. If you look in Quora, the Q&A site, there's 100 plus. Sorry?
Choose what here, because it's last when you see in there.
Sorry?
If you can choose, because when you turn out.
Oh, okay. Okay, so you couldn't hear me very well. I like to look up there, but I'll try not to. Okay, so if you look on the Quora Q&A sites, there's maybe 100 plus answers. And on Stack Overflow, there's a similar number until they had to close the question because answers to this question will tend to be almost entirely based on opinions. So despite all this disagreement on the meaning of big data, there's a general agreement that what makes it big data is the fact that traditional methods and architectures are not enough to process and store the data. So the European Commission has a pot of money to make investments in new technologies with the aim of driving innovation and creating jobs in Europe. And in 2014, they asked us, which is a commission led by the Barcelona Supercomputing Center, to try to find out the best way to make investments in hardware and networking for big data in order to get the best value for money. So first question is, why are we messing about with hardware in big data? Big data analytics is about monetizing data, and hardware isn't an asset, it's a liability. And in fact, hardware doesn't really matter as far as we may think to you guys. But hardware does matter actually to Microsoft. So Microsoft is using field programmable gate arrays, or FPGAs, which is a technology normally used for prototyping hardware to accelerate their Bing searches. And they do this because they found in initial testing that they could double the throughput on their Bing search ranking algorithm at only 10% more power. And in fact, only last week, they announced that FPGAs have been rolled out into all Azure cloud servers worldwide in order to accelerate artificial intelligence algorithms. So back to the roadmap that we've been organizing, what European companies doing. So we spoke to, we basically had 89 interviews with 70 companies, with CEOs, CTOs, companies with maybe 10 people, up to companies with 10,000 people across telecoms, Internet of Things, finance, automotive, personalized medicine. And we had 4 key findings, basically, just to kind of simplify the message. So the first one is consistent with what you may think originally, that people are still trying to figure out how to extract the value from the data that they have. They're trying to find a way to make money out of it. They're trying to find the right business model. And at the moment, they're simply not interested in thinking about hardware. That's basically the first message. You're talking to us too early. The second finding, which was very clear, is at least the companies that we spoke to in Europe are following the big guys. So basically, the big guys take risks on new technologies, they develop new technologies, they define the ecosystem. In contrast, in Europe, we have quite a lively ecosystem of small companies, but the downside of this is that we're somewhat fragmented, and there's no big player that can kind of help, that can take this role, basically. It's somewhat disorganized, and at least at the cutting edge, it's difficult to keep up. Third, the people that we spoke to said that on the hardware side, if they do have hardware, they're only interested in commodities. They want to buy hardware when it's absolutely mainstream. They want it to be as cheap as possible. They don't want any problems with it. They want it to be well tested. And basically, they're averse to taking risks on something like hardware. And fourth, very clearly, there's very little hardware from Europe. Most of the key technologies come from the US or Asia. So I know what you're thinking. Basically, I'm saying that everything is hopeless. We may as well just go home. So really, what can we do about it? So I'll very quickly highlight some of the recommendations that we made in the roadmap. So first, we see that the European Commission can help reduce the risk taken on a bet on new technologies by bringing together hardware people and software people to maybe deploy small-scale systems to demonstrate that there is a potential return on investment from maybe using GPUs or maybe using something more advanced or many core processors or something. And this is something where the European Commission maybe can subsidize these collaborative projects. And we see this as very, very valuable. Second, we see the possibility to work together to basically to tune a system for a specialized application. So again, this is hardware and software people working together. And the time is kind of right for this because changes in technology, maybe the slowing of Moore's law, and also 3D integration mean that it's beginning to become more affordable again to define solutions for kind of specialized markets. On the 3D integration front, this is, you can imagine this as moving from single-story buildings to maybe multi-story apartment blocks or multi-story office blocks. And you shouldn't design something like this without an understanding of the application, without basically involving the end users of the thing that you're designing. And the third recommendation that I'll mention today is to take advantage of convergence of high-performance computing and big data. So you guys are familiar with big data. High-performance computing is the use of large supercomputers more in scientific fields such as life science or material science, or in designing new products, or also climate and weather prediction. So speaking of high-performance computing, the Barcelona Supercomputing Center, obviously, oh really, 1 minute, okay. Obviously based here in Barcelona, operates Mare Nostrum, which is the largest supercomputer in Spain. It's one of the largest in Europe, and I think the most beautiful in the world. We have 50,000 cores, 100 terabytes of memory, 3 petabytes of disk storage, and 70% of the compute time is made available to scientists across Europe through a peer review process. We have 4 departments: computer sciences, earth sciences, life sciences, and computer applications. And very quickly, since it seems I'm running out of time, I'll highlight 2 projects that we have at BSC working in big data. So the first is that we're partners in the Pan-Cancer project, which is the world's largest project on genomics, and BSC stores the data, distributes the data to other partners in the project, and performs primary analysis on site, which we do using our SMUFFIN tool in order to answer specific questions about the role of large genomic aberrations in tumor formation and growth. The second project is a collaboration with Cisco and Barcelona City Council, where BSC is helping to define the hardware architecture to process sensor and camera data in cabinets across Barcelona. So this is the end. So in summary, BSC is a supercomputing center, but we have a large number of collaborations going on in the field of big data. And you can find out more about this at our stand. We led this project to define the roadmap for European technologies in hardware and networking for big data. I gave a very quick and superficial overview of the direction of the roadmap, but you can download the full roadmap from the project website.
Okay, let's see if I remember what I wrote in the slides. Can you hear me? Or I need to stand next to it? You can hear me, right? And back, yes? You're feeling good? Who's feeling good? So you can hear me. Great, fantastic. So I'll talk about High Optimus. So the idea about High Optimus, but how many people would know what is High Optimus? I just came up with it, so, right. Okay, so High Optimus, the idea is that we can sort of adapt our biological self to live the perfect life. Now, the interesting stuff about that is that if you look at Xerox PARC report, the recent one, they determine what determines health, right? And health, your health, is determined 20% by healthcare, 20% by genetics. So we invest a lot of money in genetics and healthcare, right? And that's 40% of our health. But 60%, the remaining bit, is about the environment. So the choices we make and environment we live in. And that's something that technology can act upon, right? So we can modify 60% of our health with technologies, and we can optimize our biological self, spending less money than we spend in genome research and in healthcare, right? Okay, so that's the interesting stuff that I didn't know before preparing such a presentation before. And most of our research is about smart cities. And you know the rhetoric about smart cities from companies. I come from Nokia Bell Labs. It's a laboratory, new laboratory in Cambridge. And we work on the idea that, for example, other companies, they're all about the smart. What is a smart city? A smart city is one in which when you go to work, you're always going to be on time. When you go shopping, there is no queue. And you know, you're going to feel really, really safe because of the CCTV cameras around you. So it's about convenience, safety, and that's what they're telling us that a smart city is, because we want to plug sensors in everywhere, right? And be smart. But in reality, we know that when we choose a city, we don't choose it for convenience and security, right? We choose a great city to live in because there is a great quality of life. And that's why I said, okay, let's start this initiative, goodcitylife.org, with people. Actually, that was the wall here nearby that disappeared. And goodcitylife.org, it's a community of people, we have 300 now, that do research that is totally orthogonal to the smart city agenda. So research that is totally pointless about what makes a good life in a city. So there are things that are really difficult to quantify, right? And so we want to empower people to say, yes, we can do work on that. That's nothing to do with sensors. There you go. Okay, so I already told you why we're doing that, because 60% is something we can act upon. And I'm going to show you two examples of work. One is perceptions of beauty. Okay, so have you watched the social networking movie about Facebook? Because maybe the title was different. Anyone? All right, so you should. You should watch it. And if you have watched it or you read a book about the Facebook starting stuff, so how Facebook started with face mesh. So basically, Mark, what he did, he built face mesh, where basically you were to compare at Harvard the hottest on campus, left or right, left or right. So pairwise comparison to get the top 10 hottest on campus. Right? This thing went viral among Harvard students, and then it became the Facebook stuff, right? So we didn't do face match again, but what we did a face match for cities. And the idea there was like, we built a website that would do pairwise comparison, right? It would ask people, which one is more beautiful between these two Google Street views? Now, why we are doing that, not because we are obsessed about doing face match, but because now we can quantify beauty. Because if thousands of people answer that question, which one is more beautiful, you actually have a rank, right? Like Mark had the top 10 hottest, you have the top 10 happiest places in the city. And if you have 100 pictures, you can actually basically quantify happiness and beauty and quietness. And that's what we did, right? So you can rank pictures that are geo-referenced, Google Street View, on the map, by beauty, happiness, and quietness. Okay, then you can look inside the pictures, and we did it with some people, Neil and Miriam and computer vision researchers back at Yahoo Barcelona when he was here. And then we could determine what is related with beauty and what is related with non-beauty, right? So what makes people happy, what makes people unhappy. What makes Londoners happy? You can read it there, Victorian red brick houses and public gardens and greenery, right? So greenery is universal. Victoria is very local to London and England, I would say. You wouldn't find the same thing in Barcelona. What makes people totally, or Londoners totally unhappy? I have limited time. So. Anyone?
The rain.
But visually. without getting wet? Anyone? Tourists. Factories. Yeah, yes. It's cars. So cars, especially fast-moving cars, are the worst possible elements you can have in a city, right? So if you have fast-moving, and you know, right, if you have a fast-moving car like this big road up here, it's not that you don't feel totally comfortable as you would feel in a small road, right? And then the second worst element was isolated buildings. Now, the interesting stuff is that these points, these images, are actually points on a map. So now the joke is, what do geeks like us do with points on a map? They connect them, right? So why you want to connect them? Well, you want to connect them because each point has got a beauty score, a quiet score, a happy score, right? And that's what we did. So while we built a new mapping tool that automatically, instead of giving you the shortest path between A to B, is going to give you the short path that makes you happier. So it's happy, beautiful, and quiet. So instead of walking 20 minutes, you walk 22 minutes, and the experience is totally different. General thing is that we are all basically doing research to change your daily habits by a really small delta, but it's giving you a totally different experience. All right. Then this thing actually, and I have like 3 minutes left. These things, we tried in Boston and London, and the user said, oh my God, why companies are not doing that? We thought, oh, well, we are companies, but anyhow. And then I said, there are a few things missing, one of which was odors, right? So people would say, okay, I actually go every day to the subway station in London, and I take the parallel road that has got a bakery shop because it wakes me up. So, okay, fine. So we need to work on odors. And why odors? Well, look at your nose, and you're going to be very in line with this conference. It's a big data machine. So your nose can, in theory, smell more than 1 trillion different kind of odors, right? So it's a sort of important. But if you look in city planning, city planners actually focus on 10 to 20 odors. And those are the bad odors. Why is that? 3, 2, 1. Because, not because they are lazy, there is just one guy in London who does that, because it's very hard to measure. And how do they measure it? People complain about it, and he acts upon it. So people complain about bad odors, and we don't care about the rest. So imagine this gigantic pie of 1 trillion different kind of odors, and we care only about 10 odors, right? Just a line in this gigantic pie. Okay, so you can measure it with the nasal rangers, but I wouldn't advise it. So we partnered with Kate. Kate does her PhD at the Royal College of Art, and for her PhD, she went around the world for 3 years, and she asked people to smell stuff and to report on a pen and paper what they smell. So over 3 years, we collected 280 words that are urban smell descriptors, right? Keywords related to urban smell. And now we match it with the picture tags that you leave when you upload the Flickr Instagram pictures. And then all of a sudden, not only you can actually build a sort of dictionary, this is the first urban smell dictionary, where you have example words in the outer part and categories and subcategories. Now, for the first time, we are giving a language to people to describe urban smell. And now, all of a sudden, not only you can focus on the bad stuff for smell, but you can focus on the positive side of smell. You can sort of celebrate smell. And you can build technologies that do that, right? Now, of course, the problem is validation. So Instagram users are very special, and also the Flickr users were special. So we work with some epidemiologists, and we check whether air quality indications, in terms of indicators, in terms of nitrogen dioxide, are actually correlated with the picture tags, and they're actually strongly correlated. So on average, at street segment level, these things go hand in hand. Nature tags, a really low quantity of nitrogen dioxide, traffic emission words, really concentrated where you have a lot of nitrogen dioxide. Okay, and then you can do all sorts of things, what are emotions related to urban smell, food and nature, they're positive emotion, metro and waste, they're negative emotion. And then just to conclude, I'm gonna show you a video that magically will start in the next 5 seconds, if eventually someone will press play. But if they won't, okay, they pressed that play. So basically, this is an example of like looking at traffic-related words in the dictionary I show you. This is London. You can map the entire city. So now, for the first time, you can reach the scale of the entire city. You can do that with each category. This is nature, right? In the wheel, you remember there were 10 big categories. And the other categories was food, for example. I won't do that for all the 10. But that's like you can map the foodscape of the city for the first time. All right, so we call the project Smelly Maps. And now we're basically, the idea here, just to conclude, is to actually find a city scale, and we have that for 11 cities now, including Barcelona, what people find visually beautiful, what do they smell? We did a project on sound, chatty maps, what do they hear? And then what are the relationships with well-beings, emotions, and especially well-beings, right? So if you understand this relationship, you can actually build technologies that optimize, right, the well-being and the happiness of people, and you get, just to conclude, the I-Optimus idea that people are thinking about nowadays. Thank you very much.
Hello. So I'm going to talk about a very different thing from what the previous speakers talked about. It's benchmarking and data generation. This is an important issue, and this is something we believe both at Sparsity and DAMA-UPC. All what I'm going to talk about comes from an FP7 funded project called LDBC. LDBC stands for the Linked Data Benchmark Council. The objective of that project was basically creating a benchmarking organization which already exists. It specializes in graph and RDF technologies, but it actually creates an ecosystem of companies and users of big data that are actually interested in general and not only in the graph and RDF technologies. At this moment, LDBC is formed by Oracle Labs, IBM, SAP, Huawei, and other companies, among which we have Sparsity as well. I, together with Peter Bonks from the CWI, are the leaders of this organization. So let me talk a little bit about what benchmarking is about. Benchmarking is basically about having data and schema that describe a business. It is about having workloads that show the type of interaction that the user ends up having with this data and schema. As I'm saying here, we have this. Is it working? I don't know. It's about, for instance, transactional, business intelligence, analytics. Within the Linked Data Benchmark Council, we are working on 3 different benchmarks on social, on 3 different workloads within the social network benchmark, which are transactional, business intelligence, and analytics. As you may imagine, for the analytics workload, we are working on big data and big graph analytics platforms. Okay. Benchmarking is also about performance metrics. How can we compare systems fairly so that the end user can decide which is the adequate system for their needs? And also auditing rules. We have to be fair in terms of how we proceed in the benchmarking process, right? Among all these, our group and company have been specializing in one specific topic, which is big data generation. In this, we believe that big data generation is, in fact, data, as a matter of fact, is the most important aspect of many businesses because it contains sensitive and critical information. And at the same time, the holders of this data are, in a sense, reluctant to share their data for different reasons, like, as I'm saying here, privacy, or even because they have a competitive advantage over their competitors so that they don't want to share this data. But all this can lead to limiting the growth of the data economy for some companies. Some small companies that are starting, they don't have the right agreements with the companies that really have their data. And as I'm saying here, this can truncate business opportunities. So based on that, we believe in the need for anonymized big data generation. There are many use cases, medical data, where it is necessary to analyze, and it's very difficult to release, as you may imagine. City data, and this understanding how people move. There are a lot of mobile data, but they are not released. So how can we generate data that emulates or simulates how people are moving in the city? And also, for instance, migrant data. Now that we have this big issue about migration in Europe, how could this data be used in order to alleviate the absorption of these migrants? So we need to generate data, we need to generate patterns of how people move around when they arrive in an area, in a geographic area, right? So the Big Data Engine platform is basically a joint effort between Oracle Labs, Sparsity, and the data management group, not data mining, sorry, it's data management group at UPC. This is the basic architecture for the generation of data. So we may have an original data and schema that we don't want to release, so we need to analyze this data. This analysis will lead us to hidden schemas that we may have in this data, either if they are structured or not non-structured, correlations among the data, distributions, structural properties, and also dictionaries. Out of that, we can create, through a data generator, data synth, a set of data. This relies actually on a big data cluster platform. In our case, we are using Spark. So I'm going to skip this. We have this generic data generator that accepts the schema, specifications, and data properties. It is extensible through plugins, so anyone can use it. It is designed to scale on clusters, and it is totally open source. You can access it through this GitHub repository. It is still on an alpha state, but we are working on it together, as I was saying, with people from Oracle Labs. What's up to this? Doesn't... vale. Okay. So I'm going to skip these two, and I'm going straight to the conclusions. We strongly believe in the future of big data generation. We believe that many companies are going to need that. Having data which scales, and at the same time, it gives realistic properties about the use cases it depicts, is going to be very important. This is going to really create a model that will allow small companies to grow and companies to have their own business analytics if the proper data is generated. So we are very open to collaborate with either companies. We are now working together with Oracle. They are not Oracle Labs. They are not close to any collaboration with any other company or research group in terms of growing this platform, making it open source, and allowing people to use this platform as their own, one of their own assets. Okay, so thank you. That's it.
Hello, nice to see so many people here. My presentation will provide the bird's eye view on the big data domain. So we will see where we are, where we should go, and how to get there. So probably during these days you have heard about different bird's eye views, but let's consider that this presentation will be the view of another bird, of one more bird, let's say. So big data success still seems to be quite elusive. Many companies believe that big data will just magically generate the business value and will magically answer the questions, will provide the answers to everything. And this is not always true. According to the recent reviews, a high percentage of companies actually end up with having very little benefit from big data projects. And one of the reasons is that actually the companies want to get the answer while the question is not actually formulated. And one of my colleagues, who is a big fan of Hitchhiker Guide to the Galaxy, he proposed a nice parallel. He said that, well, actually the situation with big data is somehow similar to the story from this book. And the story says that the aliens invested a lot of, well, millions of years into the development of a supercomputer. And then they asked the supercomputer, please give us the answer to the life, universe, and everything. And then the supercomputer took another millions of years for the analysis of data, and finally it just gave the answer, 42. And it was like the magical number, but which did not have any meaning. And the aliens were upset, but actually the supercomputer said that, okay, since your question was not very clear, any answer can be as good as another one. And this somehow describes the current situation. But besides of this, we can mention that big data generates actually big myths. Some of them are specified here, like one size fits all. It's all about technology, and data equals information. So in case of one size fits all, it's the common opinion that some tool which works good for solving some specific task in some company can be applied to solving similar tasks in all other companies. And this is not true. It's all about technology, just big data is Hadoop or Spark or Hive, and it's again not true. And data equals information. Well, no matter how big is the data, but if it does not have valuable information, then actually actionable decision-making cannot be done. So there are different data sources which are surrounding us, social network streams, log data, sensors data from the emerging Internet of Things. Some experts try to formalize the term of big data, and currently we have the 6 Ws, but the number of Ws is continuously increasing, so we will end up with the full alphabet in some day. But at this time we have volume, velocity, variety, veracity, viability, and value. These are characteristics which might describe the big data. However, in case of velocity, for instance, this characteristic is especially typical for streaming data, but it is less typical for huge batched historical data. So, but the interesting thing is that big data, the big deal with big data isn't just the data. And here I can mention one anecdote which nicely describes the situation. Imagine the company manager who is flying across the desert in the hot air balloon. And then this manager gets lost. And then he just sees a man with a camel below him. And he asks this man, where I am? And the man with the camel answers, well, you are 42 degrees, 12 minutes, 20.2 seconds north, and 122 degrees, 18 minutes west, and 212 meters above the sea. So the manager says, okay, thanks, but are you the data analyst? And the man answers, yes, but how did you know this? Then the manager answers, well, you gave me a lot of accurate information with a lot of details that I even don't need, but I still don't understand what should I do. So we should take into account that the big data projects must be solved with the teams that have different perspective. Business perspective, these are the people with the domain knowledge, scientific perspective, technology perspective, and also we should not forget about the human values, because we are moving to the human-centric era in IT, so we should remember about data privacy and social responsibilities of the business. And so I would like also to provide the roadmap, but please consider this just as a guideline for approaching the big data projects, but this guideline is not absolutely exhaustive. It can be taken just as a starting point, as an idea. So it is the good practice to start big data projects from formulating very clear strategic goal, which can be just described with SMART mnemonics. The goals like understand why the online sales of a product have dropped by, let's say, 10% in the last quarter, let's say, such high-level goal. Then this goal can be transformed into the specific questions. The answers to these questions should help to reach the goal. And we can define 4 different basic types of questions, like what happened, why did it happen, what will happen, and how can we make it happen. So, for instance, in case of online sales, maybe there were some negative opinions of users about the quality of the products or whatever. Then each of these group of questions is actually linked to some specific group of analytics approach, which can be classified into descriptive, diagnostic, predictive, and prescriptive. Then, once we specified the high-level goal, the concrete questions that we should answer, which are linked to the domain, after this, we can go down and move to the scientific approach, to the concrete techniques and algorithms that we should apply for answering these questions. And only after this, we go down to the technology stack. Okay, so how we will create the infrastructure, which data engineering tools will we need. But the sequence should be in this direction. It should be not performed in the opposite direction. Okay, and just to end up the presentation, I would like to highlight some topics that should be considered in the future. So sometimes big data is associated with a big brother. Therefore, data privacy, of course, must be considered, and especially the ethical aspects of the sensitive data. The next one, distributed mining. In the scientific society, this research direction is quite hot, and because it is not so trivial to parallelize data mining and optimization algorithms, and still a lot of efforts should be put here. Then, Actually, as maybe you have heard about this joke of some scientists, that the Bangladesh butter can explain 99% of the S&P 500 index movements. So of course it is just the joke, but the idea is that that the data is like the person. If you interrogate it too hard, it will tell you anything. So that's why claims to accuracy are might be misleading. And finally, there is the hyper focus on benchmark data sets. And actually, according to some studies, only 1% of scientific literature interpret results in the domain context. But the rest of scientific papers either use synthetic data or use the data from the UCE repository for machine learning. So it's important also to interpret results in the concrete domain for particular algorithms. Okay, so thank you for your attention.
Okay, thanks to all the speakers. I think we have heard everything. I mean, we have a very interesting talk about privacy and the role of deep learning in privacy by Oriol. We had an interesting talk about hardware and high-performance computing by Paul. We saw something very interesting about the societal impact of this research and about deriving new forms of value by Daniele. We spoke about data, particularly about synthetic data generation by Josep Luis, and about the process and the importance of having clear goals and actionable results by Liana. So now we have a very limited time, and what we're going to do is to take perhaps 3 questions from the audience, and then we will hear the questions, and then we'll pick them by the people here. So, questions. There is no lunch without questions, guys. So, questions.
Everything was clear.
It was excellent, yes. Very great talks. I have my own questions, but I was told to focus on you guys. So. Okay, the topics are very heterogeneous. So instead of that, I will throw some questions. You lost your chance, guys. So okay, there is a common topic that I heard in 2 or 3 of these talks about about some discrepancy, and you can take this question in whatever form you want. But there is on one side the people who have the data, who have access to the data, who own the data. On the other hand, you have the people who have the technology and the capabilities to understand how to process this data. You may have the hardware and the machines necessary to analyze this data, and you may have the people who have great ideas about how to do something and how to extract value from this data, and then the people who can benefit from the usage of this data. And it seems that these 5 groups of people are not always together, right? So you have some misconnection between the people who can analyze, the people who own the data, the people who want to analyze the data, and so on. So or the people who have ideas on how to do this. How do we solve this problem of this being diverse and dispersed groups? Everybody, let's start in the order of the presentations. Oriol, so what do you?
Okay, so this is a tough question in the end, right? Because each of these roles actually have to have a deep understanding on what they're doing, and actually each of them can be really depth. So mixing everything together for one person is probably not viable. And the only way to somehow share this is to create communities, definitely. But it's still a tough thing, because in the end, everybody has its own, let's say that, business plan or business project. So it's tough to put everything together into one just stuff. I don't know if that's precisely what you're talking.
So these techniques you show for, I mean,
Yeah.
anonymized data can somehow smoothen some of these things?
Well, definitely yes. I believe that it's in the right track, because in one of the speech, I believe it was John Lewis, was talking about people is concerned either by privacy, but also because it also gives a benefit for the company. It could be an advantage not to share data. And if we don't have data, actually Liana said, okay, there are lots of articles working on UCI data sets, and the reason because of that is because they are very difficult to find benchmarking data sets. So definitely, if you are able to somehow create data sets that actually preserve privacy or help into that direction, that would definitely be one way of smoothing things out.
Okay, thanks. Thank you, Paul.
Okay, do I need to press something on this?
Right.
Oh, okay, so you can hear me. So this is kind of along the lines of what I mentioned in my talk with the collaborative projects. And it's something that is actually very difficult, of course, as was just said. It's something that at least the aim of some of the projects that we're involved in that are funded by the European Commission is precisely to bring together different expertise. We have a project called Mont Blanc, which is run by BSC, which has hardware expertise and also kind of application users. But for all these projects, it's very difficult to get clear communication. It's also something, maybe I shouldn't say this, but also in institutions like the BSC, which has a different departments, it's very difficult for them to communicate anyway, even if they're in the same institution, because obviously the people care about very different things, right? So, and they speak different kind of languages, different technical languages. So it's very hard to kind of communicate and to be open about sort of, you need a willingness to learn from basically the people with the complementary expertise. So I think maybe that is actually the key aspect, that people need to be open, and they need also some reason to work together. I think that's where these kind of European projects can be useful, because people are incentivized. They kind of have to work together. If it's something that maybe you'd like to do one day, but everyone's too busy, then it doesn't happen. So maybe it's not a clear answer to the question.
But some common
that's
goals.
Some ideas. You need common goals,
Okay.
exactly.
Excellent. Daniele, so for your side, this is really about like the people who can bring some value and think outside the box with this data, and the people who actually have the data, and the people who don't have it. Like,
Yes. So I mean, the question was like, these things tend to be separate. How do we sort of put them together, right? So operation is really easy. So you need to pick the people who have two characteristics. They're bloody good at what they do. And the second characteristic, they need to be open-minded. So we know quality is distributed as a long tail. There are a few people really good at that. And you need to pick that. Among those, you need to pick the open-minded ones. Open-minded means that they accept other disciplines and they accept others' way of working. So we know that some people are really good at networking, some people are really good at thinking, these kind of things. So if you get the best and the bloody good and the ones that are open-minded, then you have a recipe for success. Recipe for failure is to apply for EU projects and think about that you can do research on that. The other thing that is related to the discussion, I like to be controversial. The other thing that...
Okay, you will be controversial in like 20 seconds more.
Yes. So, but I mean, 10 seconds. The other thing is a bomb. No, the other thing we were saying before in a coffee break was like, oh, Barcelona doesn't have a school of excellence for data, right? Mm-hmm. And why is that? I think it's cultural. I'm Italian, so I know how we deal with elitism, right? By picking the best 10 students in the whole country, giving them the opportunity to study for free with the best of the best, they're gonna produce stuff that you even don't think about, right? And the investment is gonna be minimum. So it's a shift of mind, I think.
Thanks. So we have like 1 minute left, so I'm sorry to have to pressure.
Okay, so in fact, LDVC is about this. LDVC is about putting together practitioners, putting together technologists, putting together hardware manufacturers. The basic idea is to create benchmarks which are actually down to earth, which are depicting realities. They are depicting not only from the data point of view, but also from the workloads point of view, making sure that the whole benchmark is really going down into the problems that the software may have or the hardware may have. So we are very much into that. You are invited to our technical user community meetings, which are held every 6 months. Next one is going to be down in SAP's SAP headquarters. So, and the previous were in San Francisco, New York, Barcelona. Yeah.
Diana.
Well, in my opinion, that's all about the structured, adaptable approach, which can provide, the GEAR mechanism where different specialists may represent different wheels or gears that all work together in a synchronized manner. So I personally do not think that, I personally think that scientists, for instance, should mostly concentrate on their disciplines, on the algorithmic work, while managers should mostly concentrate on the business work and technicians on the engineering work. But the question is how all these specialists interoperate with each other. So in my opinion, this is the question of the structured roadmap or some approach, the one which I suggested at the high level, but it should be detailed and maybe with the iterative approach. So this is my opinion.
Excellent. I think we heard like 5 really great presentations, and I thank the speakers again. Thank you very much.